Okay, question. We want to determine whether the rates of change are increasing, decreasing, or staying the same as we move from the left to the right, as x goes to positive infinity means as you're traveling to the right for this given function here. Now, you should know the basic shape of this function looks like a check mark. It's basically half a parabola opening up on its side. So we're going to start by looking at where this graph begins. You know that 6x plus 13 has to be greater than or equal to 0, which means 6x must be greater than or equal to negative 13. X must be greater than or equal to negative 13 over 6. Because if I was to plug that value into the formula, you would know you would have exactly a 0 under the radical, which is our very first point on the graph. Negative 13, 6 for x produces a y value of 0. So I'm going to make a quick rough graph of this function. So here's my x-axis, my y-axis, and my x-axis. Now, I'm just making a rough graph. You should notice that this graph starts off with a negative x value, and a y value that is 0. Just adjust that for a second. Sorry about that. Okay, so I have a negative x value and a y value that's 0, which means I'm going to be on the x-axis just a little bit over to the left, and the graph is opening up like a half parabola in this direction. That is my function. Now, a rate of change. What is a rate of change? It is the formula y2 minus y1 over x2 minus x1. Now, you might be thinking to yourself, that's the slope formula. Yes, it is the slope formula for a straight line, but if we look at our graph, this is clearly not a straight line. However, if I look at this first point here and maybe a second point on the graph, and I connect these 2 points with a straight line called a secant line, then the slope of this secant line would be the rate of change of my function between these 2 points. And this is the first rate of change I'm going to look at. Now, if I was to grab another point a little bit further out, point 3, and if I was to connect point 2 and point 3 with another secant line, good enough, then that second secant line would also have a slope, and that slope would be the rate of change of the function between point 2 and point 3. Notice, on the first secant line, the slope of it is larger than the slope of the second secant line, which means the rate of change between the first 2 points is larger than the second 2 points. So my rate of change is decreasing.